Good day, grade 11s. Today we are still continuing with our Euclidean Geometry series, and today we're still going to be focusing on the different types of theorems that we've been talking about even in our previous video. This is just to remind you of the different theorems or the different terminologies rather that we use in circle geometry. There's what we refer to as a segment, which is just that shaded part there. And then there's what we refer to as a chord, which is that line that creates our segment. And then there's a diameter, which is a line that goes from one circumference to the other and passes through the center. And then there's a radius, which is the line that goes from the center of the circle and it goes to the circumference of the circle. We also have an arc, which is just that part of a circle. It's like a curvy line like that. And then there's also a tangent also, and then which is just the line AB there. It touches the circle at one point. In this case, it would be at point G. That's what we refer to as a tangent. Now, these are the clear and concise definitions of an arc, a chord, a radius, which are the terms which we had in the previous slide. They are defining for you what a diameter is, what a segment is, also what a tangent is. So an arc, it says that an arc is a part of the circle or the circumference of the circle. So it's just that curvy line which I was talking about there. And then a chord is a straight line joining the ends of an arc. So a chord is drawn on the circumference of the circle to the other circumference, but it does not necessarily have to pass through the center as our diameter has to. So a radius is a straight line from the center of the circle to a point in the circumference. It goes to any point in the circumference of the circle. And what you need to know is that all the radiuses of a circle will be the same. Or also a radius is half of our diameter. And also remember a diameter, it goes from one circumference to the other and passes through, always would pass through the center of the circle. We also have a segment. The segment is just part of the circle that is cut off by that chord that we have. And then a tangent also, which is the line that contacts the circle at one point. AB is the tangent to the circle at point P, which I talked about in the previous slide. Now today we're focusing on the theorems based on tangents. Remember, a tangent is a line that touches a circle at one point on its circumference. So it touches a circle at one point. Now, looking at the circle that we have here, the tangent for our tangent, it will be P, the line PQ, it will be our tangent, and it touches the circle at point B, sorry. So it touches the circle at point B only once. So PQ, it will be our tangent. Now the theorem says that any tangent that you draw to a circle, it will always be perpendicular to the radius. And then the reason for that is what we refer to as radius OB is perpendicular to tangent PQ. Now we just write tan perpendicular to radius or radius perpendicular to tangent. That's our reason here. So any radius is perpendicular to a tangent drawn to the circle. Now again, we have theorem number 9. The numbers do not necessarily matter, but it's just where these notes, they just wrote the theorem numbers. Two tangents are drawn to a circle from the same point outside the circle and are equal in length. Now, take this for example, PA and PB, those are two tangents, and they are at a common point on the circumference of the circle. Now, we say that line or tangent PQ, PA, sorry, and PB are equal. That the reason we use we say that it's tan from common point or tangent from common point. That's another theorem that we need to take in mind. So as a result, line PA is equal to line PB. Now we also have another theorem which is called the unchord theorem. This is used or loved by many people. What this theorem is saying is just that it says that the angle between a tangent and a chord is equal to the angle subtended by the same chord in alternate segment. Now, if we take a look at the first circle that we have there, or the first circle that we have there, we have tangent PT, and then it subtends, it is subtended by also, okay, it also has a chord which is AP. Now, take a look at angle A1. A1 is an angle that is between a tangent and that chord AB. Now, if you look at the angle subtended by the very same chord which is AB, it will be angle F, which is at the top there. So as a result, we see that angle A1 is equal to angle F. You see, and also angle G also is subtended by the very same chord which is AB. Now, as a result, we see that angle A1 also is equal to angle G. Now, again, if you can check, angle A2 there is an angle between the tangent and also the chord, which is AG. The angle A2 now, we're going to say that is equal to angle B. Why? Because angle B is subtended by the very same chord, which is AG. So the reason that we use we say it's tan chord theorem. Now, if we look at the two bottom circles, now looking at the first one, which is on your left, also there's a tangent which is PT, and there's also a chord which is AB. You see, and then angle A1 is the angle between the tangent and the chord AB. Now that angle is equal to the angle C, or the angle subtended by the same chord which is AP, which is going to be in this case angle C. Now as a result, we say that angle A1 is equal to angle C. The very same thing applies to angle A2 and angle D, or angle B in this first circle on your left. In the right circle, it would be angle A2 and angle D. So that the reason that we use here is the angle between a tangent or a chord, or we just say tan chord theorem. That's the easy reason we use. Now, again, before we take a look at any questions in this Euclidean geometry section, we need to also know or remember the different properties of triangles, or the different types of triangles that we learned in the previous grade. So I'm just going to quickly talk about that in this slide, and then we're gonna take a look at questions in another video. Now, we have three types of triangles. We have acute, we have an acute triangle, right triangle, and obtuse triangle. Now, I want us to focus only by identifying them by side. Now, we usually use these names like called equilateral triangle, isosceles triangle, and scalene triangle. Now, in Euclidean geometry, there's a lot of uh, different questions like to involve these different types of triangles. Now, first we have an equilateral triangle. An equilateral triangle is a type of triangles which has all the three sides being equal. And then an isosceles triangle also is a triangle which has two equal sides. A scalene triangle is a triangle which has no equal side at all. Now let's go back to the equilateral triangle. What we need to know here is that all of the angles of the equilateral triangle will always be equal. All of the three angles will always be equal. Now in the isosceles triangle, only the two base angles or the two angles at the top will be equal. The angle at the, the two base or the angle at the bottom, angles at the bottom, not at the top. So the two base angles will always be equal, not the angles or the angle at the top. Now, the scalene triangle will have no equal angles at all. So this angle will not be equal to the other angle, will not be equal to also the third angle. So that's what we need to know. Remember, there's also a right angle triangle which has 90-degree angle. And there's also an acute triangle and also an obtuse triangle. So these are just properties by angles and then by side. Now those are the properties of triangles that we need to remember before we can do any questions here. But we need to take this into consideration when we do any questions in Euclidean geometry.